Hello guys, in this video I'm going to tell you about functional programming. So we'll see the apply function, the lapply function, that is for list. We'll see what is the sapply function. We can see how you can use split with lapply and sapply, and then we'll see what is tapply, what is mapply, and then how you can vectorize a function using mapply, and then how you can use the function named as vectorize to vectorize a function. Yeah, so that's the content for this video. Let's get started. Okay, so the apply function. Okay, say I have a matrix. Okay, so here I'm defining a matrix. It'll have the elements 1 to 6 and it'll have two rows. Okay, so let me just do this. Okay, so it has two rows and 1 to 6 numbers. Now you can use the str function to see what are the arguments of any function. So here apply is a function, user inbuilt function. So if I do this, it tells me, okay, apply takes x, it takes margin, and it takes some function. Okay, and then it can also have an argument simplify is equal to true. Okay, so now here you can see, say I use the function apply, so I have to give it a. So a in this case is our matrix. Margin is 2, so margin actually is which margin do you want to apply a particular function. So say this is the function that I want to apply, and I want to apply it on margin 1, suppose. So what this will do is it will apply max function on all the rows. So the max of 135 is 5, max of 246 is 6. Okay, the same thing if you do 2, it applies max function on columns. So 1 2 gives the max of 1 and 2 is 2, max of 3 and 4 is 4, and max of 5 and 6 is 6. So that's what the apply function is for. So you give any function over here. Say if I give mean, so it will calculate the mean of the values. So if it is 2 over here, the mean of columns. That's simple. Okay, so this is more faster. I mean, you can always use a for loop to do this, but using these functions apply will actually, this function apply will actually speed up your operation. So if the length is very big, you will see the difference. So it is similar to what we have seen in data frame videos. Okay, so now you can also define a function. Say I've defined a function, my function, which is nothing but the sum of x of square. So here I assume that x will be a vector, and what the function will do is it will square all the elements of x and then add them up. Okay, so this is a function that I created. Now when I use apply a to comma my function, oh, I did not run this. Okay, so when I apply a over my function, what happens is it is over columns. So what it'll do is 1 square plus 2 square. So that is 1 plus 4, that gives me 5. Similarly, 3 square 9 plus 4 square 16, that gives me 25, and so on. Okay, you can do that over 1 as well. Yeah, so 35 and 36. So that is 1 square plus 3 square, that's 9 plus 25, so that'll give you 35. Okay, and likewise. Okay, now if you actually try to use a list, okay, so here let me define a list L, and this is how L looks like. Now what happens if I try to apply a list? Okay, use a list for the apply function. Okay, so it gives me this error, dimension of x must have a positive length. Okay, so if you actually see a dimension of the list, so dimension of list, it gives you null. So a list actually does not have any dimension according to R, or it gives null value. Okay, so apply can be used only to those functions, or only to those variables which have a dimension. Okay, so that applies to arrays and matrices. Hence you can only use apply function for either arrays or matrices. You cannot use the apply function for list. However, if you want to use apply for list, you can use something that is known as lapply. So that is list apply. Okay, so this is how it looks like. So when I use say lapply, I have my list that I just defined earlier. It looks something like this. I've just commented so that you can understand. So this is my list, and what you can do is you can just type the function name over here. Notice that there is no margin over here because list does not have dimensions, but in apply you also need to specify the dimension. Okay, yeah, so here you can see that it worked. So the first element is 1 2 3. It gave the mean. The mean of 4 and 5 is 4.5, and the mean of these values is this. Okay, you can also change the function. I mean, you can put any function over here and then it will work accordingly. Okay, so lapply is nothing but apply for list. Okay, you can also define a user defined function. So here I've made a change. So now it is like sum of x square plus 1. Okay, so when you execute this and then execute this, so what it'll do is it will square all the terms. So it'll be 1 square and then add a 1. So 1 square plus 1 is 2. 2 square plus 2 square is 4 plus 1 5, so that becomes 7. And 3 square is 9 plus 1 10, so that gives me 17. Okay, something like this. So you can use any of the functions, user defined or inbuilt functions. If you want to use it with a list, you have to use lapply, as simple as that. Okay, now let me create a new list which is having equal number of elements. Over here you can see equal number of elements. Now you cannot use apply as mentioned earlier because a list does not have dimensions, so it says dimension must have a positive length. Okay, however, if you see the result of lapply, the lapply's result, whatever it returns is also a list. Okay, however, if you want this result to be something else, if you want it to be matrix or something else, then for that you use sapply. Okay, we'll come to that in a moment. Also, we can also have functions that return a vector. Okay, so here I have a function that takes only one input or one argument a, and then what it does is it returns a square and a cube. Okay, so if I use lapply using this other function that I've created, what happens is, so if this is my list 1 2 3 4 5 and this, so what other function will give me is 1 square, 2 square, 3 square, and then 1 cube, 2 cube, and 3 cube. So that's how. So we can also use vector outputs as well. Okay, similarly over here 4 square, 5 square, 4 cube, 5 cube, that comes from here, and so on. Okay, so yeah, so this is also possible. And yeah, coming back, okay, so if you see the result of lapply is a list. Okay, however, if you want the result to be something else, I mean if you want it to be matrix or something simpler, then you can use sapply. Okay, so this is how the function is. It is exactly similar to lapply. The only difference is if it can make it a matrix or a vector, it will do that. So if you see the L new that I defined over here, L new, yeah, L new that I defined over here, this had 3 elements per three. The length of the elements in the list were the same. Okay, so when I use this with sapply, it actually gives me numeric. So that this is a vector basically. So this gives me a vector. However, if I used lapply over here, suppose I use lapply, this would give me a list. Okay, so if you want to work with simpler data types, then you can use lapply. Okay, so that's how. Okay, over here, okay, so it's like this. So it can convert result. If it can convert a result into a vector or a matrix, then it will do that. Sapply will do that. But over here, if you see, so here I had this other function which gave me two outputs. So if I use the other function with L, which had unequal lengths, then it would give me a list, because this has unequal lengths, right? So it cannot make this into a matrix, and hence sapply will also give you a list. But if I use the new lnew function, oh, I don't know why it's there too. If I use the lnew function, then it will give me a matrix, because this is convertible. I mean, you can make this as a matrix because it has equal number of elements. Okay, so sapply is basically lapply, but if in the result, if you can convert it into a vector or a matrix, then sapply will convert it to a vector or a matrix and then output the result. Okay, so that's how sapply works. So normally people use sapply and lapply with split. Okay, so to demonstrate that, let us just import a data set, uh, air quality. So for air quality, you will require library data set. Okay, so here this is our air quality data set. It has ozone, solar, something, wind, temperature, month and day. Okay, so for every month and day, it tells me what was the ozone, solar, wind, and temperature. Okay, so this is the head, the first 6 columns, and these are the last 6 columns. Now what you can do is, say you split air quality by month. Okay, so here I'm splitting air quality by month. What this gives me is, it tells me, it gives me a phi that says all the air quality for month 5, then, so that's this, then all the air quality for month 6, month 7, and so on. So it gives me a list of data frames. If you see S over here, class of S is actually a list. So this is a list of data frames, and yeah, oh, I had done a class of X. Okay, so this is a list. So what you can do is, you can use this. So over here, what I've done is, I've made a mean function. So this is a user defined function that I'm creating, a mean function. What it'll do is, it'll take an input X. Okay, and what it'll do is, say column means. So column means will basically just give you the mean of the column. Okay, this is again an inbuilt function, column means. So X is our input argument that I'm going to give. So it will just take the ozone and the solar of X and take the mean of that. Okay, also if there is any NA value, then you'll remove that. Okay, so let us see. So now I have this function, a user defined function that I have, and I have sapply. Okay, so remember S was nothing but this split data frame that you just created. Okay, it has the values of air quality for every different month. Okay, and when you do this, so this gives you the mean ozone and the mean solar radiation for the different months. So for the month 5, 6, 7, 8, 9. Okay, you could have a different parameter over here. This is totally on you. So if you say temperature, if I just want, yeah, temperature is right. So it will give you the mean temperature for the different months. That's the okay. Now if you use lapply over here, this will give you a list. So now you understand the difference between lapply and sapply. Lapply actually gives you a list format, which is not very simple, but sapply will try to convert it to a simpler form, like a matrix if possible. Okay, so that's the difference between lapply and sapply. Okay, now coming back to vectors, what if I want to do something similar? I mean, something like split for vectors. Okay, so say I define a vector over here. Say A is a vector that I have defined. Uh, Notice the values of A. So I have 1, 2, 3, 4, 5. Then I have 100 or something, and then I have 200 and something. Okay, so what I can do is, if I want to just take the mean of first 5 values, the mean of these values, and the mean of these values, what you can do is you can use tapply for that. Okay, so how? So for that, first you'll have to create some index. So tapply requires an x, an index, a function, and then some other things. Okay, so I mean these are not compulsory, but you can see what they are. So yeah, so if I want to just calculate the mean of the first 5 and put it somewhere, and then calculate the mean of these and put it somewhere, and the mean of these, so what I do is I give it an index, so that is I. So see how I've defined I want, so repeat is a function that will repeat 1 5 times for me. So 1 will be 5 times, so in some sense I'm grouping the numbers that I want to be together. So I want these 5 to be together. Then I want these 5, these 6, these 8 to be together. So I'm telling them 2. So these are, say, group 2, and these are group 3. So basically you can group a vector with different lengths. You can see this is 5, 8, and 7. And then use tapply. Give it the A, that is the vector that you want, I, the index which you want to group to, and mean. Mean is the function. Okay, so here you can see I got the mean of the first 5, then I got the mean of this, that's 103.5, and then the mean of this, that's 203. Okay, if you change this by any chance, so say this, okay, so let's say this is 3 and this is 10. So now what happens is it gives me the mean of the first 3, and then the second group starts from 4 to 7, and the third group starts from here. Okay, so your index basically groups your vector, the numbers in the vector, using I. Okay, so like this you can actually group different elements of your vector and then perform a function over that using TF. Okay. Also there's an argument simplify over here. So if you put simplify is equal to false, it'll give you a list. If so the default is true. If simplify is true, you'll get a vector in this case. But yeah, a simplified version of whatever it is. Okay, so you can decide what you want. Okay, so that was tapply. Coming to mapply. Okay, so mapply is like a multivariate apply. Okay, so say I have a function, so R norm is a function, inbuilt function. What it'll do is it'll generate a normal random normal variable, or a random normal number for me. How many numbers? So it'll generate 5 numbers for me. So you can see 5 numbers are generated with mean 1. This is the mean, and standard deviation 2. Okay, let me just write this. I forgot. So R norm will generate random numbers from a normal distribution with mean 1 and ST2. In this case 5 random numbers. Okay, so if you make this as 6, you'll get 6 random numbers. Okay, so these are with mean 1 and standard deviation 2. If I do mean 10, you'll see that these numbers will be somewhere around 10. If this is 100, the numbers will be somewhere around 100. Okay, so something like that. So this is your R norm function. Now what happens when I do this? So 1 to 5, so I'm giving a vector over here. So this is like the length, but then let's see what happens if I give a vector 1 to 5, and then this is again a vector, Okay, I'm giving these different elements, and then this is the standard deviation. So remember, this is the mean and this is the standard deviation. Okay, it gives me this output. So it is generating uh, five numbers, five random numbers. You see the first number is using the first mean, that is 1. So this is somewhere close to 1. The second number is using the second mean, somewhere close to 10. The third number is close to third mean. Fourth number is using this mean, and the fifth number is using this mean. Okay, so you can also give vectors, but however here I have given 1 to 5, and then this generates like this. If I just do 5, it still gives me 5 numbers with the similar configuration. So 0.7 is close, is from this mean, 9.7 is from this, 98 is from this, 998 is from this, and then 9996 is from this. Alright, so 1 to 5 or just 5 is actually giving you a similar output over here. However, if you use mapply, so this is like multivariate apply, what it does is, it'll do this, it'll run a for loop, and it'll say, okay, I want one number, only one number with mean 1, and standard deviation 2. Then I want two numbers, so this will become 2. So this is a vector like this, right? 1 2 3 4 5. So then it'll say, give me two numbers with a mean of 10. Give me three numbers with a mean of 100. Give me four vectors with a mean of 1000, and five vectors with a mean of 10,000. Something like this. Okay, so over here you can see this is different. Now if you just give 5, what will happen is it'll give you 5 numbers with different means. So 5 numbers with mean 1, 5 numbers with mean 10, 5 numbers with mean 100, 5, oh these are like this. So 5 numbers with mean 1, 5 numbers with mean 10, 5 with 100, 5 with 1000, and 5 with 10,000. So you can notice the difference between mapply and a normal function that you use. Okay, so this in some cases making you or allowing you use vectors in functions. Rnorm was a function, so you are able to use a vector, so that is this vector in the function. Okay, so that is one example. The other example is, suppose I create my own function, some norm function. What this does is it takes a n value from the user, a mean and a standard deviation. What it will do is it will, so n is assumed to be a vector over here. My function is like that. Okay, n should be a vector, mean should be a scalar, and standard deviation should also be a scalar. So this should be, so the output is like n minus mean upon standard deviation. This is the output, and take the sum of that. Okay, because n is a vector, so a vector minus a scalar will give you a vector, divide by scalar will again give you a vector. Okay, so this is what I want. Okay, let's see what happens. Okay, so say I give a vector, so 1 to 5, that's n becomes 1 to 5, which is a vector. 1 is a scalar, 2 is a scalar. This works. So internally it is doing this, so it is doing 1 to 5 minus 1 by 2. So what happens is you do 1 minus 1 by 2 plus 2 minus 1 by 2 plus 3 minus 1 by 2 plus 4 minus 1 by 2 plus 5 minus 1 by 2 divide, that's equal to 5, and you get 5. Okay, so this and the function that I've defined is the same. Okay, however, if you put two vectors, if I do 1 to 5, 1 to 5 two times, actually the mean should be a scalar, but if I put a vector over here, it gives me 0. because internally what it is doing is it is doing 1 to 5 minus 1 to 5, which will always be 0 in all the cases. So it will be like 1 minus 1, 2 minus 2, 3 minus 3, 4 minus 4, 5 minus 5, which will always be 0. So hence it is giving you the output 0. However, what if I want it something like this? I want I want this to be a vector and then use every element from this once. So something like this, 1.125 vector minus 1 by 2. So that will be the first element. Then 125 minus 2, that will be the second element. Then 125 minus 3, that should be the third element, and so on. You get that? So here in some sense you are telling R that I want this to be a vector, use it together, and if there is a vector over here, split it into elements and then use it with using a for loop. Okay, if you want to do something like this, you can also do that using mapply. So what you do is you put mapply, uh, give the name of the function. So say sum norm is the name of the function that you want to use. Now here what I'm doing is this 1 to 5. So let me come here. So I'm saying the n should be a list. So what I want to say is keep n together. By this I am telling R to always keep n together. Okay, so the first variable was n. Because I've specified n should be together, so this is like this. I'm just telling always keep n together. And now this is the second element, that is mean. This is the mean, and then 2 is nothing but the standard deviation. Okay, so yeah, so since n was specified over here, it took the second argument as the first argument over here because n was specified. Okay, and this will actually give you something that you actually wanted. So in many cases it's like you want to define a certain certain element as a vector, as in this case, and then the others are scalars. And even if you put a vector over here, you want more elements, that is you want to split it like this. So then in those cases this is very useful. Okay, so if you feel that this is a bit complicated, then what you can use is you can use the vectorize function. Okay, so so vectorize in R actually means to create a for loop over that. So let me just, so most of the R functions are vectorized, meaning that the function will operate on all the elements of a vector without needing to loop through and act on each element one at a time. Okay, so in other sense, vectorize is nothing but uh, you can loop over that within the function. So that is what we mean by vectorize. So if you want to do that, so we can also use the vectorize function, inbuilt function in R. And here it's like, so you want mean and as standard deviation to be a scalar. That means if mean and standard deviations are vector, you want to loop over it, right? So what you can do is you can use them over here. So let me type mean comma standard deviation. So let me just tell you what this function is. So here I'm using the function vectorize. I'm making a new function. So the output of this function is again a function. This is a new function. What it will do is it will vectorize sum normal. So the first input is sum normal, that is my normal function, the sum normal function. So I put that in the first, and then I define what arguments do I need to vectorize. Okay, so here I want mean and standard deviation to be vectorized. That means if mean and standard deviation are not a scalar, if they are a vector, if they are not a scalar, if they are a vector, then you loop over it. Okay, so this will actually give the same result as mapply in the previous case. Okay, so let me just go through this. Okay, so we had this as our input, right? So we gave 1.5 over here. So this was the output that we got, and you can see that here also we get the same output. Okay, however, if you make this to 1.6, you get this output. That means, so over here, what do I mean by 1 to 6 is that now I'm giving 6 means. So now there's one more 6 that will add up in this summation, so that'll be 6 means. Okay, so yeah, so this gives, sorry, the second is the mean. Okay, so this gives the same. Okay, also just to make things more clear, so over here I had initially told that n should be a list. So the first argument here is actually the mean, because n is specified here in maple, so this is the mean and this is the standard deviation. However, when you use the vectorized function, you are using the function as a whole, so it has the same arguments as the original function had. Hence this is n over here, this is the mean, and this is the standard deviation. Okay, so yeah, so you can, I mean, change the number of means. So the length of the mean will actually determine the length of this. Also you can also change standard deviation as well, so you can have, say, 2 to 8. So this will also give you the different standard deviations, numbers with different standard deviations as well. Okay, so yeah, so that was this thing. Okay, so that was all. We saw the vectorized function. We saw how we can vectorize functions in R. We saw the different M apply, L apply, S apply, T apply, etc. So that's this video. Thank you so much for watching. Thank you.